हेलो एवरीवन, स्वागत है आपका मेरे यूट्यूब चैनल दी स्टैटिस्टिक्स एंड मैथ्स क्लासेस में। दोस्तों, इस वीडियो में आज हम डिस्कस करने वाले हैं डिटर्मिनेशन ऑफ सैम्पल साइज के बारे में। यह फर्स्ट पार्ट है जिसमें सैम्पल साइज डिटर्मिनेशन का इंट्रोडक्शन और क्या क्या इन्फॉर्मेशन रिक्वायर्ड है सैम्पल साइज कैलकुलेशन के लिए, इस बारे में डिस्कस करेंगे। स्टार्ट करते हैं इंट्रोडक्शन से। Determination of sample size is a critical step in any scientific research. It is necessary for two reasons. First is, the result become invalid if research is done on smaller sample than required. And second is, wastage of resources is prevented as the work will be done only on required sample size. डिटर्मिनेशन ऑफ सैम्पल साइज एक बहुत ही इम्पोर्टेंट स्टेप है किसी भी साइंटिफिक रिसर्च में, क्योंकि यदि हम सैम्पल साइज छोटा लेते हैं तो जो हम इससे पैरामीटर एस्टिमेट करेंगे वो इनवैलिड हो सकता है, और यदि हम सैम्पल साइज ज़्यादा ही बड़ा लेते हैं तो ये वेस्टेज ऑफ मनी, टाइम एंड लेबर हो सकता है। किसी भी साइंटिफिक रिसर्च में एक एप्रोप्रिएट सैम्पल साइज का होना बहुत ही आवश्यक है। Sample size calculation requires some information without which correct sample size calculation will not be possible, such as anticipated population proportion or prevalence, estimate of population mean and standard deviation, etc. Some of this information can be obtained from literature search. In rare instances, this information is not available in the literature. It can be obtained from pilot study. सैम्पल साइज कैलकुलेशन में स्टैटिस्टिकल हाइपोथेसिस एक इम्पोर्टेंट रोल प्ले करती है। स्टैटिस्टिकल हाइपोथेसिस इज अ डिक्लेरेटिव स्टेटमेंट अबाउट पैरामीटर्स ऑफ पॉपुलेशन। इन एनी रिसर्च स्टडी देयर हैज टू बी अ रिसर्च क्वेश्चन। For the purpose of statistical analysis, this research question has to be stated in terms of a statistical hypothesis, which will be confirmed or rejected based on the collected data. For example, mean systolic blood pressure mu1 in normal subjects of 30 years of age in the population is equal to 120 mm mercury, that is mu1 is equal to 120. Percent of babies born with low birth weight to anemic women P1 is greater than that in normal women P2, that is P1 is greater than P2. Mean cholesterol value in hypertensive patients mu1 is greater than mean cholesterol value in normal patients. These are all the examples of statistical hypothesis. Statistical hypotheses are two types. First is null hypothesis and second is alternative hypothesis. Null hypothesis is denoted by H0 and alternative hypothesis is denoted by H1. First is null hypothesis. Null hypothesis means there is no significant difference or association or correlation. In null hypothesis, our assumption is that the observed difference or association or correlation is due to sampling variation. Null hypothesis का मतलब होता है no difference, no association, no correlation between the groups, और जो observed difference होता है वो सिर्फ sampling variation के कारण होता है। For example, mu1 is equals to mu2 means mean of one group is equal to mean of the other group. P1 is equals to P2, that is proportion of population in one group is equal to proportion of population in other group. And R is equal to 0 means there is no correlation between the groups. H0 accepted when p value is greater than 0.05, otherwise it is rejected. Second type of hypothesis is alternative hypothesis, which is denoted by H1. Alternative hypothesis means there is significant difference or association or correlation. In alternative hypothesis, the observed difference or association or correlation is real and not due to sampling variation. अल्टरनेटिव हाइपोथेसिस का मतलब होता है कि जो हमें ऑब्जर्व डिफरेंस और एसोसिएशन और कोरिलेशन दिखता है वह सिग्निफिकेंट होता है और रियल होता है, वह सैम्पलिंग वेरिएशन के कारण नहीं होता है। अल्टरनेटिव हाइपोथेसिस दो टाइप की होती है, वन साइडेड अल्टरनेटिव हाइपोथेसिस एंड टू साइडेड अल्टरनेटिव हाइपोथेसिस। फर्स्ट इज वन साइडेड अल्टरनेटिव हाइपोथेसिस। A one-sided alternative hypothesis claims that a parameter is either larger or smaller than the value given by the null hypothesis. For example, mu1 is greater than mu2 or mu2 is greater than mu1, and p1 is greater than p2 or p2 is greater than p1. Second type of alternative hypothesis is two-sided alternative hypothesis. A two-sided alternative hypothesis claims that a parameter is simply not equal to the value given by the null hypothesis. For example, mu1 does not is equal to mu2 and p1 does not is equals to p2. In this type of alternative hypothesis, direction does not matter. Alternative hypothesis accepted when p-value is less than is equals to 0.05. इसके बाद है टाइप फर्स्ट एंड टाइप सेकंड एरर्स। यदि नल हाइपोथेसिस ट्रू हो और इसे रिजेक्ट किया जाता है तो यह एक रॉन्ग डिसीजन होगा जिसे टाइप फर्स्ट एरर और अल्फा एरर कहते हैं। यदि नल हाइपोथेसिस ट्रू हो और इसे एक्सेप्ट किया जाता है तो यह एक करेक्ट डिसीजन होगा जिसे कॉन्फिडेंस कोफिशिएंट कहते हैं और 1 माइनस अल्फा से रिप्रेजेंट करते हैं। यदि नल हाइपोथेसिस फॉल्स हो और इसे रिजेक्ट किया जाता है तो यह करेक्ट डिसीजन होगा जिसे पावर ऑफ टेस्ट कहते हैं और 1 माइनस बीटा से रिप्रेजेंट करते हैं। यदि नल हाइपोथेसिस फॉल्स हो और इसे एक्सेप्ट किया जाता है तो यह एक रॉन्ग डिसीजन होगा जिसे टाइप सेकंड एरर और बीटा एरर कहते हैं। So type first error alpha is equal to probability of rejecting H0 when H0 is true. Type second error beta is equal to probability of accepting H0 when H0 is false. Confidence coefficient 1 minus alpha is equal to probability of accepting H0 when H0 is true. Power of test 1 minus beta is equal to probability of rejecting H0 when H0 is false. Type first error more serious than type second error. For example, in a case control study, an alpha error would mean conducting that an association exists between a suspected risk factor and disease. But in reality, this association between these two does not exist. So, we accept the risk of alpha error to the extent of 5% and we accept the risk of beta error to the extent of 20%. Now, next is common information required for sample size calculation. Some information required for sample size calculation without which we cannot estimate an appropriate sample size. First is study design. The formulae for calculation of sample size are different for different study design. Thus, formula for case control study will not be useful for a clinical trial. Second information required is alpha error and confidence level. Alpha error is the significance level set by the investigator before start study. It is probability of rejecting null hypothesis. Usually we accept an alpha is equals to 0.05, then confidence will be 0.95. Higher the confidence level, higher will be the sample size. Third information required is beta error and power of test. Beta error is the probability of accepting a false null hypothesis. Beta error is set at a higher level than alpha error because beta error not serious than alpha error. Usual level of beta error accepted is 0.2 or 0.1, then power of test will be 0.8 or 0.9. Higher the power of test, higher will be the sample size. fourth information required is precision. This required when we are trying to make an estimate of population parameter from sample statistic. The parameter being estimated could be a proportion, mean, difference in proportion, difference in means, odds ratio, etc. Precision is defined by minimum and maximum value of the parameter that we want our sample to detect with preset degree of confidence and power. Precision could be defined in absolute terms and relative terms. So first is absolute precision. It is the number that is independent of expected value of population parameter. Suppose we want to calculate sample size to know prevalence of diabetes in population. As per literature, suppose prevalence of diabetes is equal to 5 per thousand and absolute precision is 2. It means that we want our sample to detect prevalence if it is 5 plus minus 2, that is 3 to 7 per thousand. Now second is relative precision. It is the number that is dependent on the expected value of population parameter. If expected prevalence of disease is 10 per thousand and we want to detect it with 25% of relative precision, it would mean 25% of 10, that is 1.25. Thus, we would expect sample to detect prevalence if it is 10 plus minus 1.25, that is 8.75 to 11.25 per thousand. Relative precision is usually set to 20 to 25% of the expected value of parameter. The only difference between the absolute precision and relative precision is absolute precision does not depend on the expected value of population parameter, but relative precision depends on the expected value of population parameter. Now, fifth information required is types of alternative hypothesis. There are two types of alternative hypothesis in any test of significance. These are one-sided alternative hypothesis and two-sided alternative hypothesis and represented by AH1 and AH2. AH1 means mu1 is greater than mu2 or mu1 is less than mu2, and AH2 means mu1 does not is equal to mu2. We use one-sided alternative hypothesis if one group is superior or inferior than other group. Higher sample size required for two-sided alternative hypothesis than one-sided alternative hypothesis. Sixth information required is design effect. If the sampling method adopted is not simple random sampling method, the sample size is to be corrected using the design effect associated with sampling method. The design effect is the ratio of two theoretical variances for an estimator. Design effect is equals to 1 plus rho into n minus 1 is equal to variance of cluster sampling is divided by variance of simple random sampling, where n is equal to average number of subjects sampled per cluster, rho is equal to interclass or intercluster correlation coefficient, and is calculated by sigma b square is divided by sigma b square plus sigma w square, where sigma b square is variance between the cluster and sigma w square is variance within the cluster. In a well-designed study, the design effect usually varies from 1 to 3. Calculation of design effect is very complicated. So usually design effect is taken as 2 for cluster surveys. Design effect is taken as 2 for cluster surveys. Now, the last information required for sample size calculation is Z values. The Z values are the statistical constants associated with alpha and beta errors that are set. These will be automatically decided when we decide these error labels and type of alternative hypothesis. Z values associated with alpha and beta errors. If alpha is equal to 0.01 or confidence is equal to 0.99, then Z value for one-sided alternative hypothesis is 2.326 and Z value for two-sided alternative hypothesis is 2.576. If alpha is equal to 0.05 or confidence is equal to 0.95, then Z value for one-sided alternative hypothesis is 1.645 and Z value for two-sided alternative hypothesis is 1.96. If alpha is equal to 0.10 or confidence is equal to 0.90, then Z value for one-sided alternative hypothesis is 1.282 and Z value for two-sided alternative hypothesis is 1.645. If beta is equal to 0.05 or power is equal to 0.95, then Z beta is equal to 1.645. If beta is equal to 0.10 or power is equal to 0.90, then Z beta is equal to 1.282. If beta is equal to 0.20 or power is equal to 0.80, then Z beta is equal to 0.842. Thank you so much guys for watching this video. Second part of this video will be uploaded as soon as possible. So please subscribe my YouTube channel and press bell icon.